All right, so it's going to start with Horst and Ralf Doerner from University of Applied Sciences, talk about Virtual Reality Forge, pattern-oriented authoring of Virtual Reality Nuggets. There we go.
Okay, good morning everybody from this side. Today I'll talk about the Virtual Reality Forge. So, today I'll talk about the Virtual Reality Forge, which is a pattern-oriented authoring approach for virtual reality nuggets. And as this work is quite interdisciplinary and based on related concepts in the educational sciences, we start by looking into the learning concept, which is located in the area of microlearning. So then we will have a closer look on what VR nuggets are and what system design we propose. So we reflect this educational approach and apply it in the area of VR and its authoring. I'll present to you how we evaluated the VR nugget concept, and then we will see how we integrated it in a, let's call it a lightweight VR authoring system to be operated by laymen. And we will conclude this talk with some thoughts on future work. So let's start right away. What are learning nuggets and what is microlearning in general? So a paradigmatic trend within the current e-learning domain is called microlearning, and it divides large and complex knowledge structures into relatively small and reusable units called learning nuggets. And sometimes this approach of structuring learning content is referred to as bite-sized learning, since learners get quite very small, comprehensible learning parts after another. So a bit more formally, how do educators author such content or integrate such bite-sized nuggets in complex structures? Basically, it's the other way around. They chunk down knowledge structures into very elementary nuggets, and then by connecting them, they build more complex structures from it. So by arranging them, they form highly diverse curricular structures like courses, presentations, demos, and so on. So what is such an elementary learning nugget? Well, these independent and self-contained nuggets each reflect and implement patterns, which are derived from, for example, best practices of certain domains. So nuggets are quite reusable as they rely on patterns. Let's have a more tangible example here. One of these very basic patterns may be a compare pattern. For example, we may visually compare apples with oranges here. Okay, so for this we have an image of an apple and an orange side, and we focus on similar or maybe contrary aspects of it and point them out with some text annotations. If we now wanted to compare apples with bananas with the same visual compare pattern, we all might imagine how this may look by using the same kind of visual approach. So we could reuse all aspects that we had on the apples, and furthermore we only alter the facts of the banana, and so we still work with about 2 images and some text line connectors. So I think we can agree that it's far more easy to change the content when the frame is already given, instead of starting 2 graphics from scratch. So now, what has this educational trend got to do with VR actually? Well, as a matter of fact, experts already use very different kind of media to implement these conceptual patterns as such learning nuggets, such as images, videos, emails, SMS, even posters. But you may have guessed it, not among them is virtual reality as a medium. So experts don't know how to apply VR in this trend. Another way around, we do not know how we can reflect this trend in a VR system. So in order to facilitate VR as a medium for microlearning, our overall goal is to use 1 or more self-contained VR systems in such a lesson or a presentation in a very nuggets-like way. And therefore we try to provide a system design that dovetails this straightforward microlearning concept. So we introduce the VR Nugget system. In each VR system we conceptually distinguish three major parts which we handle separately. The first part is a specific part that we call VR Nugget. The second part is an optional part that can add functionality called functional coatings. And the third part is a very basic part that combines all the remaining runtime functionality that a VR system needs. So like asset management, rendering, data handling, etc. Basically all that the domain experts might not want to come in contact with. We call this part the VR Nugget platform. And we illustrate these components down here to make their relation to each other more clear. As indicated by the shape of the component, the VR Nuggets kind of snap or are attached to specific positions in the platform. So, as the VR Nugget is the very central component, it reflects the pattern, which then can be utilized within our VR system. And by separating it from the rest of the system design, we assure that authors can choose among educational patterns as they did with other media. So, VR Nuggets have parameters that authors need to assign values to. These parameters differ from each pattern. So the parameterization ensures that basic pattern implementations can be reused as templates for very similar purposes. Let's take an example again. Let's think again of the pattern that compares two objects, in this case the two stars here, with at least one but maybe more comparisons, and a comparison is made up from lines and titles, similar as with the apples and the oranges. And to implement a compare pattern, for example, the VR Nugget now might ensure that at least two objects are given, in this case an orange and a green box. Besides what content, a VR Nugget also holds information about where to place these initial objects, and for example which interactions are possible within this nugget. So for a compare VR Nugget, again, the two objects are possibly placed very close to each other. Visual cues for comparisons of the objects can be activated by the VR users. So for this example, users probably do not have to grab and rotate objects, but only look around, walk around, and activate such comparisons. Now, in general, these VR Nuggets are kept quite basic, as the learning Nuggets are, to provide quite high reusability and flexibility. But because of that, our VR system now is not quite content specific anymore. So they are quite one abstraction layer above working while working with such pattern solutions. And we introduce a concept to compensate this, or at least to counteract it. That's where the functional coatings come into play. These stackable parts can add up supplemental functionalities to each of the distinct nuggets, and therefore extend them. So, for example, one coating may provide VR users the functionality to grab and rotate these main objects now. Another on top may put a decent particle circle anywhere in the room to attract the user's attention for this nugget. And the last one may add any background sound or music, and so on and so on. So we try to provide quite a high-level adjustment layer if you want to. So we can add supplemental functionality, but which does not alter the utility of such a VR nugget. Meaning it does not alter the underlying intention of the pattern that we choose, which might be, for example, to compare two things as a learning goal. And using this proposed approach, we build an example application for, in this case, educating people about a hydrogen fuel cell. Educators of the local university wanted to inform users about the structure and the operation of such a fuel cell, which was quite difficult. So Therefore, the demo should be augmented by VR nuggets as a suitable medium to present 3D structures. So they would use VR during this demo very infrequently, switching to other media, switching to other nuggets, maybe to posters, to presentation slides, and so on. And we identified 5 suitable patterns for this prototype with consultation of the domain experts and implemented themselves as self-contained VR systems. On the right, we see 2 examples, a show and tell and a chronological sequence pattern. So, for evaluating the proposed pattern-oriented VR authoring method, we addressed whether domain experts find this approach helpful and whether they appreciate it for being learning nuggets. As I speak now of the domain experts, they are when we speak of the domain of educational sciences. So, 4 aspects regarding an application of VR in this area are considered here in the study. The first one is the time. So, do users of VR nuggets have a VR experience at all? Do they feel present in VR despite the anticipated very short utilization time? The second aspect was the acceptance. So, is the implementation of the VR nugget concept accepted by educators? Then A3, the recognition. So, how do users perceive visual similarities between implementations of VR nuggets? So, as we use such, let's call it templates, there for sure are visual similarities between different implementations. So, the last one is the reusability. So, kinda, how is the reusability of the VR nugget concept assessed by educators? And for the evaluation, we conducted an expert user study. The expert user study involved 17 unpaid voluntary participants, 10 female between age between 26 and 52 years, and they were recruited from secondary educational institutions. All experts had at least 5 years of educational experiences and 5 years of theoretical studies in the educational sciences. So they all held a master's degree of education or a comparable degree. And they have never or only very few used VR. And what did we do with the experts? At first, they were introduced to the topic and the hardware. Then the experimenter held a very short presentation about basic functionalities of the fuel cell that you saw before, while the experts took the learner role in this scenario. During this session, VR nuggets were applied infrequently within the study, so participants had to use VR several times during this presentation, but they also had to put on and take off the VR HMD during this learning session several times. 6 nuggets were implemented. 6 nuggets implementations were used during the study in the same order, while 2 pairs of them were based on the same pattern, but were reused with different content as we proposed it. And the session was conducted within 20 minutes. After this task phase, the participants were asked to fill out a questionnaire that incorporated items of 2 standardized questionnaires and further items specifically about the VR nuggets. So to make statements about the presence concerning a very short usage, we used the established iGroup presence questionnaire. This questionnaire measures the overall presence relating to 3 established factors: the spatial presence, involvement, and experienced realism. Relating to the acceptance, we made use of the AttrackDiff questionnaire to measure the overall attractiveness of our prototype to experts based on the hedonic and pragmatic quality. High values indicate positive experiences in both of these questionnaires. Indications about the recognition and the reusability, so A3 and A4, were captured by 3 Likert and 3 semantic differential scale items that were used additionally to these 2 standardized questionnaires. Okay, then we analyzed the outcome of the questionnaire, and here we see the outcome of the IPQ as box plots. We can see that except experience realism, all medians are above the neutral value of 3. So for the overall experiences, which is for the overall experience, we conducted an additional Wilcoxon-signed rank test against this hypothetical medium of 3, which could show a significant difference, which is quite good. And here we see a graph about the attractive rating, measured against the hedonic and pragmatic qualities. As I said, it illustrates that the experts quite accepted the VR nuggets well and placed the overall ratings within the desired region, where they were only slightly overlapping with, in its confidence, with self-oriented and task-oriented areas. So, for now we indicated a relatively high presence and high acceptance of the system, but concerning A3 and A4, participants stated that they found the different VR Nugget implementations quite similar in general. They furthermore stated that they discovered that similar single elements were used and that similar educational concepts were underlying these distinct implementations. The participants indicated as well that they personally liked this similarity between the nuggets, so the high similarity in this case, and they listed that they find this amount of similarity between these nuggets quite beneficial for microlearning on the one hand, but also for education in general. So overall right now we have indicated that our approach supports creating nugget-like VR applications for educational use. And the study indicates that educational domain experts were confident and could indicate that VR nuggets can be conceptually at least be used similar to learning nuggets that rely on, for example, other media. But as most pedagogues would be laymen in the field of VR, they still need consultation of VR experts with programming experience, so to actually create content for or with these nuggets. The VR experts, on the contrary, lack the domain-specific knowledge. So authoring process between the VR and the domain experts might be a quite tedious one. And therefore we furthermore investigated in an according authoring interface of VR nuggets that laymen may be able to operate, which is the VR Forge. And with this interface, we equip laymen with a toolkit that enables them to author VR content with predefined VR nuggets. Furthermore, VR Forge serves as a framework for executing them. We use here a presentation slide-inspired metaphor to implement both of these functionalities. It is expected that presentation systems like, for example, PowerPoint or Library, Keynote, Impress, and so on are quite common tools for educational purposes. And the interface of the VR Forge consists of 6 menus. The main menu provides the general system functionalities such as adding a new nugget to the presentation, editing notes in the presenter's view, starting the VR nuggets, deleting some nuggets from the presentation and quitting the authoring application. Up on adding a new nugget, a window which you see here appears where users can choose between predefined nugget templates to add them to the presentation. The demo timeline illustrates previews of nuggets that are already added to the presentation, which you see on the left. So users can select these nuggets here to set them as the currently active one for the VR users. The active nugget is displayed in the current nugget menu right here. Supplemental interactions for the VR users with the content of the nuggets can be assigned in the functional coatings menu in the top right corner of the interface. The navigation menu provides the authors with interactions for adjusting their view during authoring. So while such interactions are probably not necessary for 2D presentations, for example PowerPoint, it is of high importance if we author 3D VR environments. The users, for example, could position the text boxes which you see here behind the box and then cannot see them anymore during their authoring, so thus would not be able to make use of the 3D environment accurately. by providing these template implementations, that include placeholder objects of such mandatory components as the boxes that you saw, we ensure that our system always remains in a usable state right from the beginning on. So the worst that could happen is that an author forgets to replace content in it and shows an incomplete but still yet usable nugget to the audience. And during the authoring process, these placeholders are then iteratively be replaced by the resources that the authors want to show. So we assume they already have the 3D models, not like I talked before. Maybe they come from there. So the Nugget menu provides the necessary functionalities to do so. For example, replace main objects, instantiate pattern-specific content, which is in this example the text annotations. And we then also conducted a pilot study and evaluated the VRForge interface with 7 unpaid voluntary participants that described themselves as laymen in the field of VR, all aged between 25 and 56 with 2 females. After 5 minutes of free exploration to familiarize themselves with the software, participants were asked to fulfill 7 tasks relating to the VRForge and authoring VR nuggets. Thereafter, participants filled out a very brief questionnaire right now that incorporated items of the so-called short version of the attractive questionnaire. The portfolio presentation on the left of the attractive outcome indicates that the overall interface of the prototype was classified as well in the desired region, and additionally the word pair graph to your right gives further insight into single items that the questionnaire consisted of. All mean values here are located on the positive region, which likewise indicates that the prototype was positively perceived by the participants. 3 items, I guess, are closely located to the 1 point mark and show the lowest mean values in this study. Specifically 2 items, which are the items tacky, stylish, and ugly, attractive, indicate that the outer appearance of a prototype was criticized by the participants. So, which may not surprise you as you saw the quite functional-oriented prototype. So both charts indicate that the VRForge implementation was very well accepted in any way of the participants of our user study, and that the layman successfully could use the software to actually author VR nuggets. Okay, what have you seen here? On this paper we introduced the VRForge at last, which is a pattern-oriented VR authoring approach of virtual reality nuggets. With these VR nuggets, we propose a, let's call it, structured approach to foster the usage of VR in small, clearly defined application use cases that can be integrated in larger contexts. Together with experts, we indicated that the approach dovetails the learning nugget approach of microlearning methodology in VR. So what is future work? Let me quickly point out one thing. Future work, we think it's most interesting to explore if our VR nugget-based approach is not necessarily limited to the educational domain. So VR applications for other domains, such as maybe medical VR, could be created using VR nuggets as well. And moreover, using this nugget-based approach for a new application domain must not mean, or does not have to mean, that authors need to start from scratch. So existing VR nuggets can serve as a starting point to identify, for example, patterns in new domains. So using this nugget-based approach outside the education sciences, therefore, is future work. But we think it would be a nice step towards reusable VR systems. Image sources, for the sake of completeness. And thank you very much. And we have some time for questions now.
All right, first I want to say, you guys have a demo here as well, right? So, do you have a demo here? No? No? Of course, it's not the same one. All right, never mind. One thing is, where does the nugget nugget metaphor comes from. I didn't get it because nuggets for me are little pieces of gold that I get out of the river. So
yeah. Well, actually, I don't know why the educational sciences picked that name. So it was not my idea to pick this nugget metaphor, but I think it comes from well, these nuggets are the very basic components of very many materials. So if you forge them and process them, they can be, for example, gold bars at the end.
So that's the VR forge thing coming
Yes.
from. All right. Any questions, guys? Yeah.
So thank you for the interesting talk. I was wondering a little bit about the background. So it seemed quite elaborate, and I was wondering whether it's sort of like arbitrary that you just sort of design a space that looks nice, or whether there are some thoughts behind the space, or whether you think that the users could maybe design the space as part of designing the nugget.
With background, you mean the showroom, the room around the objects, right?
Precisely. You could even see out the windows, and there were little couches.
Yeah. Well, that's where well we prepared it. So it's not user-specific content, but it's also not what we aim at. So probably for the learning goals, the outer appearance may not be quite important. So what is more important for educational experts is that they do something and it works and it looks nicely. So we designed a nicely looking but not too much saying environment where they can place their basic 3D content. Maybe we could think of more templates or provide them several background environments, like one is more the scientific one, another one could be forest or whatever the content could be placed in.
I think one great way, if you want to take this up a notch, is to create some kind of like an app store for nuggets. You know what I mean? Some kind of collaborative platform where we can share this thing, functionality. I guess any other questions? Yeah.
Thank you for the presentation. So looks like the tool is mostly focusing on presenting and visualizing the content for education. Would you consider any interactivity to build into the authoring tools? I mean, adding capabilities to add interactivity into the content or any assessment items into it?
Yeah, we do. Actually, it's about presenting and visualizing the stuff, but in the nuggets there also is clearly defined which interactions do we basically need. So if we would have a, let's think of again of the compare nugget, and if we would need to grab these items, so in VR, so having these interactions, they would also be built in this nugget. So we would not use VR nuggets that are incomplete of interaction. Okay, so we reduce it to the very basic interaction, and then we have this concept of the coatings. Okay, if we need more interaction, we can use these coatings to stack up and add the functionality, but either the nuggets or the coatings have to make sure that they are compatible with each other. So that's also future work. Thanks.
All right, guys, let's thank our speaker. And please enjoy the morning.